All right, there we are. Sorry about that. So, we are live now. So, this was a viewer suggestion from a TikTok user, and they said, Matt, let's put Earth around a better star. And I said, well, what's a better star? Because I actually think our sun is, at least as far as we know, the best star. But we're going to do it around a red dwarf. So, some of the challenges associated with putting Earth around a red dwarf, it's much smaller, so we're going to be tidally locked. And so we're going to have to be a lot closer. If you see here, the habitable zone, we're very close. So 1 AU is the distance of Earth to the Sun, and we're going to be at about zero point 0.4 AU. So this would be kind of similar to if Earth was in the Proxima Centauri system. So like I said, we're just going to start out with Earth. Um, and it already looks like maybe we might be a little bit hot, but let's see here. So we're going to go to view, we're going to turn off that habitable zone. And you can already tell we have this reddish hue going here. But let's just kind of see what it does to our temperature here. So we'll get a baseline. This is where Earth starts out at. We have an average temperature of about 45.4 degrees. So let me know how the sound is in the chat, guys. And then let's rock and roll. So this is our new Earth. It's our new star. Just see what it looks like from Earth. Very hazy. Be like a hazy yellow star. Alright, speed this up a little bit. We'll get some of the other planets in here too, but I just want to make sure we're like in the habitable zone here. And really, I think we should be tidally locked, so I'm just going to manually tidally lock it. Alright. See how the gravity is. Well, the gravity is going to be more affected by Earth. I don't think it's... Obviously, if we put other planets in closer to us. Let's see here. Oh yeah, I wanted to tidally lock it because I do believe there is a... Yeah. Because it should be tidally locked this close. So now we are locked. And this is how we think most of the planets, the inner planets around Proxima are anyways. So a lot of the possibly habitable planets that we're looking at, they would be tidally locked. It's very interesting here. So you see, obviously, the the Earth stopped spinning, but the atmosphere did not. So that is just causing a really interesting effect there. I'm gonna turn off realistic lighting here, just so that we can see everything. Space goggles. They've changed this around quite a bit. Ah, there we go. Flashlight. Here we go. That way we don't have to see the dark side and the light side. So we have the clouds here still moving. I wonder what that's just going to mean. So what that's going to do for the surface, though, is eventually we're going to have a completely frozen side and like a completely boiling side. And scientists think that on planets like this, there may be a habitable zone sort of in the twilight area, right on the edge of the tidally locked, the near side and the far side, because obviously one side would be boiling hot, one side would be freezing cold. But we think possibly in that twilight zone it could be possible that there are, certain organisms that would be able to adapt to that. So while I'm kind of simulating this out, I'm going to add in, let's at least put in Saturn, because this is, actually let's just put in Neptune as our gas giant, because this is a far smaller star. So I don't know if we're going to want the massive Jupiter messing with everything here. So let's go ahead. We'll just do Neptune. Way out here. And then we'll add in Mars with its moons. Make sure I have the moons on. Mars. And then we'll get in. I guess we'll do Venus really close. We'll see how this works out. Why not? And Mercury. Should we just jettison Mercury into the sun? Okay. So there we go. So this sun is only 0.123 masses of our sun, only a little bit larger than Jupiter on the radius, and that's because as you keep adding mass, it's going to keep compressing. So let's take a look at our Earth here. Pause it. Do-do-do. Hope everyone's having a great night, by the way. Hey, Anna. Mercury's that way. Oh yeah, I do need to add the moon. Good point. I almost forgot about that. Boop. I think that's about right on the distance. There, we've got our moon now. Maybe that'll help us a little bit. Oh, did Mercury just crash into the sun? Oh god. Oh no. Oh, messed that up. I think I put the moon in too close. Let's start that over. Easy enough. Proxima Centauri. Pew. Okay. And then we'll just do Earth with the moon already. Yes, this is interesting because we have to put it so close for it to be habitable. So let's see here. Let's do that again. So put in Earth. And then motion. Tidally lock it again. And then, so we'll go back here, add Neptune. We're gonna have to go pretty far out for that, just to hold our little solar system together. Hopefully, maybe, was that one of Neptune's moons or something that came crashing in on us last time? Or I missed what actually crashed into us. I'll have to replay it and take a look. Might not have even really got it in the camera. So, turn off the habitable zones here. I'm just curious what's going to really happen. Like I said, we should really get a frozen side. So wherever I locked it, so sorry China and India. India, you are going to get used to cool weather. But like I was saying, scientists think that on stars like this, where we have tidally locked planets, that there could possibly be life living right on this twilight zone, possibly, hiding out in caves on the day side, and then, taking food and nutrients back over, moving over to the dark side when it's time to rest. We don't know if something like that is possible, but, obviously just something that we're thinking of, because again, I said this side we're just going to get boiling ocean, and it'd be interesting to see because what it'll really do to our atmosphere too over time. So I'm just gonna kind of let this rock for a little bit. It's kind of mesmerizing. And I said, just remember how much closer we are to this star too, just to make this work. Because again, the mass here is only 12% that of our sun. So I mean, we're doing an orbit every couple of days. So your seasons are gonna last 3 days here. Imagine having a 3-day spring, a 3-day summer, a 3-day fall. And then you're right back at it again. Yeah, and Danny, I wonder if the atmosphere is still moving, if that's an effect of me just stopping Earth instantly and it keeps the atmosphere moving. Because if the planet was tidally locked forever, you would think, maybe the atmosphere wouldn't be moving around that fast. But all right, let's see what we've got here now that we've done a little bit of fast forwarding. Slow this down. So yeah, like North America, South America, and the west side of Africa and Europe are just going to be in perpetual daylight now. We've only gone for a couple months here, so I'm gonna let it rock a little bit more. Hope everyone's having a great night. Yeah, I do think that's why, Danny, because I just abruptly stopped the Earth. So we're gonna have this just. It's like the atmosphere kept moving at the same speed that the Earth was spinning at, so. I wonder if there's any way you can make the atmosphere stop spinning too, but. Oh, yeah. I don't know if Neptune's gonna like hold its moons together out there without the help of Jupiter and stuff. Maybe it's just too far away. Gravity's a little bit too loose out here. Uh-oh. Well, that's something we might have to worry about. Let's go ahead and put in Venus. So the system's too small to put in all the planets for sure. Like, we're not going to want them. I don't know if we're going to want the mass of Jupiter. You notice we've already lost the moon. Things just aren't working the same here. Hopefully Mars will protect us from whatever comes from Neptune. Maybe if we put Jupiter really far out, it'll act as like a sort of stabilizer. What happened if the Earth stopped spinning? Yeah. Yeah, I'll get into some more fun stuff towards the end here, Danny. Let me know exactly what you mean by fun stuff, though, because I'm a nerd. This is all fun to me, so. Alright. I just want to see what happens to the temperature here. So it does look like I put it a little bit closer than I should have. Seems like I always do that. I need to start putting things just a little bit farther out. So we're getting hotter, hotter. But you see, we're getting a colder and colder minimum and a hotter and hotter maximum too. So if you're on the... Okay, so it looks like we've stabilized now. So if you're on the side facing the star, you're at about 213 degrees every day. And if you're on the dark side, you're at -85. So, looking kind of like Mars as far as our temperatures, right? And you see all the vegetation's already scorched off here. So, we're not doing much farming. Like I said, maybe some of the most habitable places would be actually like at the poles along the line here. What do you guys think? Alright, now it's time to wreak some havoc, I think. Let's give our star the binary companion. It's probably going to cause some serious issues. Do another small one. form a halt. This is pretty stable, Danny. Yeah, that first one I messed up pretty good. Yeah, we've got a nice stable system here. I think Neptune's just a little bit too far out, but I think its moons are actually going to create a little bit of a belt here. Yeah, so in real life, you have Proxima Centauri A and B that are a binary pair, and then Proxima orbits really far out. So maybe let's try the opposite here. I'll do like a really large star orbiting far out. We'll do like Stevenson or something, which is 40 times the mass of our sun. Oh no, that's just gonna suck everything right into it. We'll do Polaris B. It's just a little bit bigger than ours. Let's see if I put it in binary. I mean, this is gonna wreck our entire solar system anyways. Alright. Kind of worried. Had a nice stable system here. So let's see if it just kind of falls into orbit nicely, or if everything is going to go out there with it. Now I did cheat and I just clicked the binary button, so it should throw it into a binary orbit, but ooh, already we see all these moons going. Uh-oh. Yep. Alright, where's Earth before everything goes all topsy-turvy? Oh dang, sorry. Ah, I lost myself. Okay, here we go. Where did you go, Earth? Things are gonna get a little rough a bit. But we might lose our tidal locking. What would happen if the Earth stopped spinning? Yeah, it'd be crazy. The atmosphere would keep going. We would have just crazy tornadoes. Alright, let's just watch this whole system now. So Mars has already been kind of thrown for a loop. Now I'll be curious to see if everything is gonna, like, obviously we're gonna have some real serious tumult here, but after all the tumultuous period, are we going to actually settle in? And obviously everything is gonna, I think, really start going in towards Polaris, so this is gonna be our center of focus here. And then obviously we'll see what happens with Earth along the way. I don't want to go too fast though, because sometimes you start getting a little bored and then you speed it up and then everything just explodes and you kind of miss it. So still got a nice, you know, Earth might kind of stay in orbit. We'll see. We might get lucky because we're tight enough. We might just be tight enough that we'll stay with our star with Proxima. Let's see. Oh man. So you have Polaris, just a little bit bigger than our sun. And then we have Proxima over here, which is way, way smaller than our sun. I like Mars's orbit though. It's just doing this crazy kind of infinity loop here. Checking on Earth. Alright. Let's see, do we still have life on Earth? Maybe. Actually seems a little bit more livable now than it was before. I think we're still tidally locked. Alright, I'm gonna let it rock for a minute here. We'll follow the journey of Proxima. Proxima's either gonna fly into Polaris, or more likely it looks like it's gonna get slung around into a pretty crazy orbit, and I don't know what that's gonna mean for our new planets. Yeah, it might, Danny. I don't know. We'll see. It might stabilize eventually. Either way, this is pretty fun right now. Neptune's on a chase out here. As I have noticed though that the tighter a planet is in to the orbit of its star, the harder it is, to disturb it, obviously. So, um, we're kind of lucky that we're in tight here. 1 billion years. And I do have to say in this game too, like it says 9 years down here. I don't think the time's 100% realistic, obviously. Because things realistically are going to happen on such a grander time scale that it wouldn't be any fun if they made it 100% realistic that way, I think. Yeah, we still have our tight little spiral there. Alright, speed this up a little bit more now. Fascinating. So now we're going to get into kind of like a three body problem issue, though, where whenever Proxima starts coming way closer to Polaris, it's just going to roast the Earth, and then it's going to go farther away from Polaris and get into like a more habitable kind of time period. So let me kind of highlight over Earth here real quick, because I think we're going to start really heating up here. No more ice caps either. Oh no, a little bit of a southern ice cap. Hey, Earth might still be okay here. I thought I was definitely wrecking us here. I put Polaris far enough out, I guess. Yeah, Danny, the interesting enough thing is like you'd be surprised how many near misses can happen. Like there have been so many times I'm playing this game you think things are going to collide and they just graze by each other very close cuz I mean realistically there's so much empty space, and when you're looking at something and you think it's relatively close to hitting, it's actually not. Yeah, so Polaris is our new center of mass essentially. So now everything is chasing it. And so Proxima just kind of slingshot it around. It's going to keep coming back around. Hey Andromeda, how's it going? We are just totally messing up this system. I made a Earth around Proxima Centauri and then kind of threw Polaris in, and we actually have... So yeah, so it's going to reach this point here. And I think this line, this is like the math trying to figure out the orbit. It's not quite sure what's going on right now. And like I said, even though we only have two stars, this is kind of what happens in the three-body problem, where you just have so many different bodies all pulling on each other that our mathematical models actually get kind of overwhelmed. Whew. But could you imagine having a second star that comes closer and farther away and changes our seasons on like a millennial type scale? It'd just be absolutely wild. Alright, what time do we got? It's almost 9:30, so I'll get into some fun stuff. I actually just saw there was an update on here today. They added in Three-Eye Atlas and Oumuamua, I think, so you can kind of compare their flight trajectories and like the mathematical data we have on them. Yeah, you'd be surprised. Like, I think naturally, yeah, some things are going to get slung out, and but realistically, things will eventually kind of fall into some sort of a stable pattern. Especially just because I put Polaris so far away. I think this game's still $30. You can get it on Steam, and it's on the Windows Store. I don't know if it's available for iOS. Danny, you want to see if it's on iOS? It's called Universe Sandbox. But I know for sure it was $30 when I bought it. This game's been around since 2008, but it always has constant updates. Yes, you can. You can change all that stuff. So I could actually go. Um, where is Earth here? Yes, I mean, you can just hit this transform button. Actually, you could tilt the Earth on its side. You can change the obliquity of the orbit. Actually, when I first started manually playing this game, if you watch some of my earlier videos, I didn't actually know when you were adding planets that you could just hit the orbit button. So I was like manually changing the speed and stuff like that to try to get planets into orbit when I first started playing, and I was making it like way harder than it had to be. But they have a lot of automatic tools in it where, like as you saw when I put Earth into orbit, you can do auto orbit. You can halt the motion. Ooh, reverse velocity. Okay, we have to do that. Ooh, that was a headache, sorry. Should we reverse the velocity of the Earth? Yeah, it's still relatively cheap. Now I will say games like this do take a lot of processing power. You're gonna want like a desktop, or you're gonna want a gaming laptop or something. So you're gonna want something with dedicated graphics. Something that has a nice NVIDIA graphics card. Make sure that um, that it meets all the requirements and stuff for it. Yeah, I know. When you go too fast, it is a little dizzying. All right, where did our Earth go? Where are we? Did I hit reverse velocity? Yeah, so I just hit reverse velocity and now Earth is going. Oh, I guess it's just gonna jettison us out. Well, that's no fun. I wonder if I reverse it again, will it save us? Nope, I think we're just rogue now. I know how to save us. That's insane. So this is Stevenson 218. This is one of the largest stars that we know of. I mean, look at that. So Polaris is a little bit bigger than our sun, just for kind of a size comparison. And then that's Stevenson 218. Just massive. Think about that. Maybe that would be a fun one, doing Earth around Stevenson. Oh, you want to be a dev, hey? Nice. Yeah, you'll want to have a. I actually need to upgrade my PC for this game, especially as you add more and more elements to it. Oh man, look at Jupiter. Everything's just heating up. Jupiter might still like be okay out here. Earth's not. This is our heat map. Just getting torched. Probably gonna have a tail coming off of us. Yeah. Oh man, that's so bright. Like burn your monitors out from this. Oh yeah, we got a nice tail. So the side that's facing the star is just getting absolutely obliterated, even though it's flying away from it. Wow. Alright, supernova time. Oh no, did I freeze my computer? There we go. Say bye to our system here. Wow. Alright, let's check out Oumuamua and 3i Atlas. I thought that was pretty. So they always add in all of these different built-in simulations and stuff. And I said in the update, it said that they have 3i Atlas, so yeah, there we go. Interstellar Comet 3i Atlas. So I've actually been meaning to research this a little bit more because it's one of those. Oumuamua really interested me. Um, just so on July 21st, 2025, astronomers detected the comet 3i Atlas, the third ever visitor to our solar system from interstellar space. It'll make its closest approach to the sun on October 30th, 2025. I didn't know that's still hanging out. Around 1.4 AU away, slightly closer than Mars, before slingshotting out of the solar system. And then Oumuamua, the first interstellar object found passing through the solar system, shot around the sun closer than Mercury at 0.255 AU. And then 2I Borisov, the second interstellar object found, was much farther away, only getting as close as twice the distance of the Earth to the Sun. Now, like I said, the odd thing I remember about Oumuamua is from our initial readings, we didn't see any sort of tail, no sort of comet, like anything that would make us think that it was a comet, and then it accelerated around the sun really fast. And also from our initial readings, it was like 3 to 4 times longer than it is wide, so that's where you kind of get this famous cigar shape idea from, which you just don't see that shape in nature a whole lot. So I think that's why a lot of people speculate that it's an interstellar object. Cheap telescopes. I got a here, I'll send you the link for the one I got actually. I don't even have the Virtuoso GTI. This is the one I got. It's kind of cool because you can set it on a table first. You don't have to buy a tripod and all of that stuff for it first. So it's like $600 to start. I mean, telescopes are an expensive endeavor, so. But this is, I don't know if I can put an Amazon link in there, so I'll try to find it for you and I'll put it in there afterwards. But all right, so I want to start this simulation over though, and let's take a look at. So this is 3i Atlas and the trajectory that it's taking, and so like I said, that's actually kind of interesting. So on Halloween, it's gonna get the closest to Earth, and so I don't know about you, but I mean, if I were an alien probe, it sure would look something a lot like Oumuamua. Not saying that it is, but it's just certainly very fascinating. So this is the path it's gonna take. It looks like it should be pretty innocuous, and it's not gonna hit us or anything. But yeah, another interstellar visitor. Let's see what other. So I love some of these built-in simulations that they have here. A cool thing about this too, you can do the live view. So this will actually kind of show you, if you're ever curious, just where everything is now. And this actually has our different probes. I think we got the JWST, the Tesla Roadster. I think we got the JWST too. Yeah. So, cool fact about the James Webb Space Telescope, it actually orbits out farther than the moon. A binary planet with 2 Earths. Oh yeah, that'd be kind of fun. I'll do our all planets and all moons. So add in a binary Earth, a double Earth. I don't think I've done that before. Now our moon might not like this a whole lot. Well, let's see here. This will be interesting. I don't know how this is going to work out with our moon. We'll see. Might have to do it without the moon, but let's see if we can fall into a nice trinary orbit here with, we'll call this Earth B. Oh, it's not a binary of Earth anymore now. It's just orbiting the sun. Let's see if it... Oh, it's just falling into its own orbit. Hold on. Oh no. Oh no. Yeah, I might need something else to stabilize it. I mean, it's gonna stay, like, with us. Let's see. Oh, it does say binary of Earth. It's gonna probably switch. It's gonna say orbiting the sun, and then it's gonna say binary of Earth because it's kind of getting tugged by both. That would be kind of cool if we had a second Earth. We could just send all the people we don't like there. I'm just kidding. Oh man, could you imagine the eclipses you get from other Earth though? Oh god, that's dizzying. Where are you, other Earth? So this is our night sky. It's crazy to think that some people actually live far enough out that you can actually look up in the sky and see Andromeda. I never can. We can see stars by my house, but I can't ever see Andromeda. Where's other Earth? There's other Earth. You know, I think in a situation like this, as long as they fell into orbit, I mean, we would just have two habitable planets. It wouldn't fundamentally change too much, right? We'd have really big waves. You play as an alien and you go to a world or a habitable world and you have to help life evolve. They had, you know, Andromeda, I want to say Sid Meier kind of had a game kind of like that. Sid Meier's Evolution, maybe. And he had some, like Alpha, maybe Alpha Centauri was kind of like that, but most of his games were more, you know, because he did the Red Alert series, so they were more like real-time strategy and war-based. Um, but yeah, let's see what else we got here. Thanks for joining me. This was the last lunar eclipse. That's one thing I love about this game. Like I said, I think it's been out since 2008, but they're always updating it. Like they just had another update where they added Oumuamua and Three Eye Atlas and stuff like that. Um, ooh, a pulsar. Nanograv pulsar timing array simulation. I've never opened this one before. Let's see, I'm going to pause it real quick. When galaxies collide, gravity pulls the supermassive black holes at their centers into a binary system that emits gravitational waves that squeeze and stretch space-time as they orbit. Black holes do not emit light, so detecting these waves is the only way to confirm these black holes exist. Astronomers search for gravitational waves using a galaxy-sized array of pulsars, rapidly rotating neutron stars that emit beams of radio emissions like a lighthouse. These waves change the distances between pulsars and Earth as they move through space, causing the pulsar mission to arrive slightly earlier or later than expected. So that stretch of the gravitational wave signal increases as these delays are observed. So essentially it's saying we use pulsars to find black holes. By studying it, we can learn more about the origins of supermassive black holes and how galaxies evolve. While Universe Sandbox does not simulate gravitational waves, since they're an effect of general relativity, you can explore the galaxy-sized detector of 68 pulsars Nanograv uses to search for these monstrous black holes. I like it. So they have links here too. If you click this stuff, it'll actually take you to searching for supermassive black holes. At the center of every galaxy is a supermassive black hole, and ours is Sagittarius A star, by the way. But despite their size, they're hard to observe because they don't emit any light. And that's what's always baffled me, is that we think, you know, black holes eat everything, but yet they're at the center of every galaxy. So quite clearly, like, they don't just destroy everything, or maybe they eventually do. I know I, along with a lot of other people, have some of these weird theories that, maybe black holes are just where one universe ends and another universe begins, and it just spits stuff out into another multiverse, or who knows? Because we really just don't know. I have no idea. Whoa. One way to look for pairs of supermassive black holes that form when two galaxies collide instead of looking for individual black holes. Yeah, and that's actually, I made this point recently that there could be small, like, when I say small, I mean, the mass of a few suns, black holes that are out there just rogue, and we wouldn't be able to see them. If they're not eating anything or they're not actively feeding on stellar material, we wouldn't be able to see them at all. So, just something to think about there. Supermassive black hole barycenter. As they orbit, they emit gravitational waves. Easiest to look for when they orbit once every few months or years, like shown here. We need a detector much larger than we can build on Earth to observe them. The size of a galaxy. Oh, that's fine. I'll get started on that. Because we need to absorb many orbits to make sure that the signal's from gravitational waves. Well, if you ask a flat earther, gravity's fake. So, that solves that problem. The pulsar timing array. Yeah, so pulsars have a regular rotation, and we can use it to predict when their beams will sweep across. Sensitive tiny changes. Fascinating. Man, how long does this tutorial go for? So far, astronomers have not found any individual supermassive black hole pairs using this method. Evidence for the gravitational wave background signal, collective signal of gravitational waves, was announced by the North American blah blah blah. Alright, I'm getting ADHD here. Crap. Asteroid YR24. Oh no. So in 2032, we're going to have a pretty close encounter with an asteroid here. It'll actually fly. They think something like that. Pretty close. Yeah, anything that comes between us and the moon. Actually, a lot more objects come between us and the moon than you would think. Alright, I think I'm gonna get out of here for the night, guys. I usually go for like an hour, unless you got any more suggestions for me. If the sun turned into a black hole with the same mass of all the planets, would they stay in orbit? Probably. If it just had the same mass, I think we'd stay in orbit, but again, it would be really dark. So I don't think life would exist anymore, but I don't know. Because again, we have a supermassive black hole at the center of our galaxy, and it hasn't just eaten everything yet. Everything orbits around it still. Use 2 Jupiters. Actually, something that's kind of fun, I did this in like a short before, but it takes about like 40 Jupiters to make a red dwarf, and then it takes about, a few red dwarfs to make a sun. So you could actually just, like 1, 2, 3, 4, 5, 6. If you make enough Jupiters, it'll actually just make a red dwarf, which is kind of crazy. So that's why Jupiter is actually gas giant, and then you have a brown dwarf and then a red dwarf. But so Jupiter is actually the first class of what you would consider like a failed star, right? It's just a massive disk of gas, but there's not enough of it to actually collapse and start, any sort of fission or fusion. Uh-oh. If I broke my computer. Oh god. Okay. I'm just gonna hit new. Might need a new, some more RAM to do that. Alright. I'm losing it here, guys. Hang in there with me. How many Jupiters would it take to catch an Earth? What do you mean to catch an Earth? Alright, see you, Andromeda. I think I'm gonna get out of here too, guys. I did my first. I'll come up with a more fun experiment after next time. The Red Dwarf was fun, and then definitely throwing that second star in there was fun. But alright, thanks everybody for tuning in. Have a great night. Hope you learned something. Peace.